Our first speaker for the last segment is well known as the alias of Horse.js. I once accused you of it, and you didn't deny it. Domenic Denicola.
All right, let's talk about what is going on with JavaScript. So there's a few things I want to go over with you guys. Talk about what's going on with JavaScript today, present day, what we've been seeing recently. I want to talk about some new platform innovations, especially on the web, that have really shown how JavaScript has become a lot more powerful. And then, of course, we get to the fun stuff, where this language is going. What crazy proposals are out there that you may not have seen yet that have the potential to change the language in good or bad ways. So some of what we're talking about will probably be too fast to follow necessarily by just staring at the slide and trying to figure it out. But the good news is all the slides will be online, and it's really meant to give you a sampler of the ideas here so that you can kind of dig into them later if you think they're particularly interesting. And hopefully you'll be fairly comprehensible by themselves. So anyway, what's the big deal with JavaScript today? Well, of course, we have a new revision of the language. There's new features all over the place. And there's been a lot of talks on this, so we don't need to spend too much time on it. I just want to go through and give you briefly, what are the highlights, what works in Node.js. I put little N icons there. This is what you can use today in Node.js with no transpiler or anything like that. We've got the syntax, makes our programs nicer and easier to read. We have some data structures, allow us to program in ways that are much more efficient than we ever could before, or safer in the case of the weak data structures. We have an iteration protocol, actually. This is a pretty big deal. Finally, a standardized way for all objects to collaborate on how they get enumerated, iterated. And this is something that I think is a great example of how standards have the power to unify everybody behind a single primitive. And finally, what I think of as the most important features in the new version of the language, the game changers, the things that will really change how you write code in pretty drastic ways. And these are all kind of a big deal in their own ways, and don't want to get into them all too much, but keep an eye out for these, and especially because you can use almost all of them today in your code. So the stuff that I think where it gets really interesting, beyond just the features that you may have seen already, is how is this actually playing out in code today in the wild? It's still pretty early, but especially due to places like Node.js or transpilers, we're able to actually see some of these trends. So here's what I've noticed. The first is the way that ES 2015 has impacted our code styles. So this is some code from the jsdom project that I work on. It's my main spare time project. And we've wholeheartedly embraced these new ES 15 features. We've said, you are not allowed to use function expressions when you could use an arrow function instead, because we believe that you really only want the this behavior of a function expression if you're doing a method, right? So if you're just doing a function, an arrow function makes more sense. And we use const everywhere, and sometimes we use let. We never ever use var. That's just not allowed anymore. And we have an ESLint rule to enforce that. Of course, we get to use class syntax, and we get to use object literal shorthand to make things nicer. There's an interesting pattern here, which was a little more complicated, the use of symbols for private state. So the idea here is that you want to obfuscate your private state a little bit better than just using underscores. This isn't airtight. There's still a reflective API, object.getOnProperty symbols, that allows you access to these if somebody really needs to. But this is especially nice because when you do things like print out your object in the console or try and evolve it without people depending on the public API, you're now able to hide these things a lot more easily and kind of present the public API that you want to. So symbols are really about a number of things. One of them is about allowing you to define the public API you want. And so as I said, there's ways to enforce this kind of code style with tools, and the one we're using so far, it's not perfect and it doesn't cover everything, but it's pretty good and it's getting better, is ESLint. So I've given a little example of our ESLint config showing you're not allowed to use var, you must use the shorthand syntax, you prefer arrows in certain cases, you prefer const to let, and then we use template strings to try and concatenate strings instead of using the plus operator, which has some other advantages. Another big thing that we've seen in our code and elsewhere is using promises for all asynchronous code instead of something like Node.js style callbacks. And this is pretty great. We finally have something that we can agree upon as an asynchronous primitive for everybody to use, and has all the advantages that you normally find talked about why promises are so great and callbacks are so sad. But where it really gets interesting is when you combine it with another new language feature, generators. So this is a little hard to figure out what's going on here, but essentially there's a library called Co that we're using, and it's embedded in a framework called Koa that allows you to use the yield keyword as kind of a weight. So everywhere where you kind of try and read this code, which is an example server that I've actually written, whenever you see the word yield, think of it as a weight. So we're awaiting making a directory. We're awaiting exec a file. We're awaiting writing the file. We get to write this very nice, straightforward code flow. None of the nesting, not even any of the promise nesting or callbacks or anything, just to show exactly how errors are handled, exactly how our out flows. You get try, catch, finally, the kind of stuff that isn't easy at all in normal asynchronous programming. So frameworks that kind of take advantage of this are pretty exciting. Koa is the framework I'm using here. It's for HTTP servers, but there's others for other types of situations. There's some for writing command line applications and so on. But the main thing is that once you have an asynchronous primitive promises that your async function is going to return, that allows you to open up this kind of thing. And it's going to get better in the future, as we'll see. And some of you may know the async await syntax is coming to make this all even better. But I think this is one of the big changes that we've seen, not only in my code, of course, but also across the community, is the wholesale adoption of a single asynchronous primitive. The final trend, which kind of goes beyond ES15 in a lot of ways, is the use of Babel as a transpiler. There's been transpilers before Babel, but what Babel really did is it strongly pushed a few non-standard features as something that are built into the base. So JSX, of course, is the most famous of these, but a lot of them are also, especially Facebook-inspired proposals that have not really gone that far in the committee yet. There's no sense that they will necessarily make it into the language. But people use them because they're especially useful for programming, say, React-style apps. Or Ember-style apps is the case with decorators. So I'm showing a few examples of these features here. Decorators, property initializers, and JSX, all mixed in with standard ES6 features like class syntax and so on. So what's interesting is this idea that the language is no longer purely defined by what's in the standard, no longer purely defined by what runs in our browsers and in our user agents, in our server runtimes. It's also defined by what our transpiler will do. We don't have to go wholesale all the way to something like CoffeeScript that's a completely different syntax. We can just extend the standard syntaxes with things that aren't standard or that might become standard someday, if certain proposals make their way through. I personally err on the side of not using non-standard features in my JavaScript, especially because I get to write modern Node.js code where almost everything is already supported with a few exceptions, like we saw from the earlier slides briefly. But this is a choice, and you can certainly do whichever you need, unless you need to support Internet Explorer before Edge, in which case you need to transpile anyway. So, okay, go use whatever. All right. So that's what I've been seeing around. Let's take a break and talk about the language briefly and talk a little bit about all the cool ways that JavaScript has started influencing the platform in ways really that go beyond what we've seen before. So the foundational reason that there's so much exciting stuff going on in the web platform is this document, the Extensible Web Manifesto. It's a few years old by now, I think. It's maybe a little dry and abstract when you try and read it. But essentially what it boils down to is saying that the browser has too much C++ magic in it that isn't exposed to JavaScript. That there's too much stuff going on that you can only do if you're a browser developer. And that we really want web developers, developers who program in JavaScript, to be able to do this magic stuff too, make it less magic, demystify it. So there's 3 examples of upcoming features that I want to show you that kind of exemplify this trend and also show you how JavaScript is getting access to levels of the stack it never has before. So the first you've probably seen before is custom elements. What I'm showing here is actually a little different than what you may have seen because this is an API that's actually has a chance of becoming a standard, not just something shipped in Chrome and only Chrome. Well, the idea behind custom elements is to explain the magic where the HTML parser encounters a tag and then creates a DOM node from it. A DOM node that's instantly elements make this possible, and this has been attempted in Chrome form for years with a different API, but not everybody was on board. So there's been recently a lot of progress in getting something we can agree on. And actually the API has evolved in ways that I think is a lot better. So now you can use ES6 classes, and the same class that you pass in will be the one that's used elsewhere. You can kind of hack it in other cases, but it works better now in a lot of ways. There's changes to how upgrading works. There's changes, small changes to the callback syntax. But the idea is that, the biggest thing maybe to notice is that the constructor actually works here instead of a created callback, which was a long point of discussion and was only saved by some 11th hour crazy realizations that we could abuse ES6 in ways I don't want to discuss in public. But ask me about them later over drinks. But it's exciting to see that we'll finally maybe have custom elements in every browser with a syntax that's actually a lot nicer than what you might have seen previously from the Chrome-only version. The other big thing is service workers. Now these are also heavily evangelized, and so you might know the idea that you can now make your website work offline. You can run a worker in the background even when your app isn't running that receives push notifications and so on. But what I think is the best way of putting how service workers work is that they're a little proxy embedded in your browser, a little server in your browser that sits between you and the network, sits between your web page and the network. So the code I've written here might look somewhat similar to what you've seen on the server side in Node.js, if you do that sort of programming. The idea of setting up a router with get routes or whatever that responds in certain ways. But what's actually going on here is this is running in a service worker in your browser, saying when anybody calls a get at this URL in my app, I would like to respond in this way. And you can create a synthetic response entirely on your own, which allows some super powerful techniques. You can do things like going to the network, but only after you first try the cache. You can do all sorts of interesting things. And my favorite example to show how powerful this can get is the idea of using a service worker to polyfill new media formats. So if you wanted to deploy an image format that was only supported in 1 or 2 browsers or 0 browsers, but had much better compression, you could just transcode it in your service worker to something that is supported, PNG, for example, on the fly. Because you have this server now that sits between the web and the web page and allows you to do these sorts of things in a way that was never possible. So you just get this completely unrestricted access in a lot of ways to the layer, the network layer that JavaScript never could touch before. So that's pretty cool. The final example, which really blows my mind, is this custom paint API. So this is a little tricky to see what's going on here until I show you the next part of the example, which is this. The idea is that you have CSS that says, hey, whenever you're painting a background image or a border image or any other part of the CSS that could be specified as an image, instead, please call this JavaScript function and give it a canvas type thing that I can do whatever I want to. And that canvas type thing can look up other CSS properties that apply to the element. In this case, it's the circle color custom property. And this allows us to get a hook into the rendering pipeline, into the rendering thread in many cases, that is uniquely situated to be performant, to be called at all the right times, and to let you customize CSS. And this is just the beginning. Because custom paint is one thing, painting all these things differently, but what about custom layout? What if you were to register a new type of layout? We can do Flexbox in most browsers, we can do grid in 1 or 2 browsers, but what if you wanted to do something completely different, something like Apple cassowary style constraint-based layout? You could get the hooks at the JavaScript engine level. It passes you a callback with all the elements, and you get to lay them out. And the great thing about that sort of thing is because it's your app, because you know the requirements, you don't have to sit around in a standards body debating how your layout will interact with the 5 different other types of layout on the platform and all the crazy edge cases. And it'll actually probably end up being faster than what would be programmed into browsers because it doesn't have to account for every app in the entire world. And you'll certainly get it faster because you'll be programming it, instead of waiting for browsers. So there's a lot of cool stuff going on in this realm. If you want to look it up more, it's called Houdini, this effort to explain the magic of CSS. But custom paint is the furthest along. I believe it's either in Chrome under an experimental flag or it's in a branch, but it's something they want to ship as soon as they can get the final API ship nailed down. And a lot of browsers are on board with this. It isn't just Chrome rushing ahead of the pack this time. You know, Apple is especially excited about a lot of the Houdini efforts, and I'm pretty heartened to see that. So I hope you enjoyed hearing some of the cool things that JavaScript is being able to do these days, much more than ever before. But let's go back to the language to kind of finish things out. What does the future hold for JavaScript? Well, there's one big deal that doesn't really get a lot of press, I think, but to me at least is super exciting, and that's this URL. Now there's two really exciting things about this URL. The first is that this is the URL for the ECMAScript spec. It's on GitHub. So you can actually submit pull requests to the spec when you notice errors, when you're proposing a thing. You can submit it in a plain text format to the spec and see the diffs, see all the changes, track them in real time, raise issues, all the normal things you do on GitHub. And this is something modern specs have been doing for a while elsewhere in the web, but for the first time, JavaScript has joined them. So no more getting monthly dumps of a Word document on a Ecma wiki. Finally, modern spec development practices. The other big thing about this URL is that there's no version number in it, right? This is just one URL where you go to see the ECMAScript spec, the latest ECMAScript spec. Now there is a URL that I haven't listed here because it's a bad URL in my opinion, that has the number 6.0 in it. And that URL is already bad because so many bug fixes have been made to the spec in between the publication of 6.0 and now. The idea is you should always be consulting the latest part, the latest document to see the latest status of the spec. And this is something we call a living standard. Now, I don't think TC39 would be willing to say that they've moved to a living standard model, but in practice, there is a version of ECMAScript out there that is living and is evolving, and you should always be consulting. So that's pretty exciting. And this is really a consequence of the fact that, in general, for modern specifications, spec version numbers are complete bullshit, and you shouldn't be thinking about them. So there's a lot of talk about, oh, ES6, or oh, no, it's ES 2015, and we're really angry that you changed the name, or oh, there's going to be a new version, ES 2016, what's going to be in that? And is my favorite feature going to make it to 2016? It doesn't matter. You should never care about the spec version numbers. You should care about what's in the living standard, which reflects something that everybody's committed to implement. And you should also care about what is in the browsers you're targeting. Because there's a bunch of stuff in the standard right now that hasn't been implemented yet. Call this, proxies in Node, so on and so forth. You should never be thinking about, this feature is official because it's in the spec. You should be thinking about this feature is official because it's supported in enough places and people are using it so much that they're definitely not going to change it now, right? So that's how things work these days, for better or for worse, and I think it's actually a lot better. All right. So with all that in mind, I'm going to tell you about some of the wonderful features coming up. And I'm not going to tell you what version they're coming in because it really doesn't matter. But there's some of them that are coming soon, and there's others that are a lot more speculative. So there's just two in particular that are coming soon because they're pretty close to done. One of them is async await. Finally, super awesome asynchronous programming in JavaScript. You may have seen this before. If you haven't, definitely check out some of the many talks on it. But this is going to be great. This is what we've all waited for. And of course, it builds on promises, so get on that train if you haven't already. But it's already implemented in Edge behind the flag, and it's already in Firefox nightly. So this is actually really happening. And on V8, we're hoping to do it in Q1. We'll see. The other big thing, and this is kind of harder to give an example for, is SIMD.js. The idea behind SIMD is your processor actually has the ability to do these vectorized operations, where it operates on 4 or 8 or more numbers at a time in these little vectors. And there's no way actually in JavaScript to do that right now. So we add this kind of awkward, kind of ugly API that isn't really meant for use by humans, but does let you exploit the full power of your hardware. And mostly what you're going to be doing is you're going to be compiling from C or from other languages, perhaps with auto-vectorization, that give you this already. But it's still pretty exciting that we're exposing this rather large chunk of your computer that was never JavaScriptable before to JavaScript. So this is an example from a Mandelbrot demo showing how to make a fractal that's like 4 times faster because it uses 4 lanes of SymD stuff. So yeah. All right. So that's pretty much it for soon. But what's coming up? So speculatively, we've got a number of stuff, a number of things that are pretty cool. This is my favorite, value types. The idea of having some sort of custom values that are compared for their structural equality, not their identity, and that have custom literals saying, you know, perhaps 64-bit integers or ULs. And we can even go further. We can say colors or CSS lengths get their own kind of value semantics. And this is very speculative, and nobody really knows how to spec this, but everybody knows that this is a big gap in our language. Decorators, the idea to, we get to modify our classes at runtime. And so here's an example where you kind of just decorate this function inside a class and replace it with one that does performance measurement before and after. They're getting a lot of effort into these 39. Cancelable promises. This is something I'm personally on the hook for, have been for a while. The idea is that we want to be able to say, this ongoing asynchronous operation needs to stop. Please stop it. No matter where you are in that giant chain of operations that are subsequent to it, let's stop them. A more complicated asynchronous thing is the idea of async iterables. The idea that you would be able to loop over, you know, we have async things and we have plural things, iterable. What about an async plural thing, something that delivers you multiple values asynchronously? So there's a number of pieces to this syntax. Async for, async function star. In the end, it all ends up being pretty useful for certain cases, and this is essentially the basis of things like Node.js streams at their very lowest level. Finally, maybe eventually we'll figure out module loading. You know, right now, Babel has an algorithm. It's just what the Babel authors think is good. So when you're using Babel modules, you're just like using something they made up. This is probably what we can get agreement on is //, and absolute URLs. So if we can just, and script type equals module just around them. If we can get that working, maybe we'll finally be able to ship something in browsers instead of just transpilers. So that's wishful thinking maybe, but we'll see. All right, and that's pretty much it for the state of JavaScript, except one last thing we should talk about, WebAssembly. So if you haven't heard about this, definitely check it out. It's this idea that we're going to add like a second level to the JavaScript VM that is a type of bytecode that other languages can compile to. And it's going to be like ASM.js but better, except for maybe we'll also add threads to it and shared memory. And somehow it will be able to interface with all the web APIs. And it's definitely going to replace all your JavaScript code in 10 years, except for maybe it's not. It's just going to be used for like plugins that want to compile. Nobody really knows. There's a lot of design issues. But one thing we do know is that there's a lot of effort being spent on this, engineering-wise, in all the VM teams. So it's serious and it's happening, and something interesting is going on. This isn't just, you know, one vendor doing their project. This isn't VBScript. This isn't Dart. This isn't Knackle. This is serious and multi-vendor effort. So we'll see. Definitely know more about that next year's State of JavaScript. But in the end, I'm not too worried. JavaScript is here to stay, and it's doing pretty well. Thank you.